This is a solved 15 puzzle. Now make the smallest looking mistake possible. Swap 14 and 15. Only 2 tiles are wrong. The blank is already where it belongs, so this should be easy. But it is impossible, not difficult, not time-consuming, impossible. There is no sequence of legal slides that solves this board. To prove that, we need something stronger than a clever strategy. A strategy tells you how to move. A proof of impossibility tells you what no move can ever change. So the question is not how do we solve this? The question is, what hidden quantity is preserved by every legal slide? To find that quantity, read the board like a sentence, left to right, top to bottom. Ignore the blank. In the solved board, the sentence is 1, 2, 3, all the way to 15. In the swapped board, everything is in order except the end, 13, 15, 14. 15 is before 14. That small reordering at the end is what we're going to track. Pause for a moment. We are going to be counting something on the puzzle, so let's be precise about it. Take a short list of numbers in order. 1, 2, 3, 4. Now swap 2 of them. 1, 3, 2, 4. 3 appears before 2. That single pair counts as 1 inversion. Try a more scrambled list. 3, 1, 4, 2. 3 is before 1. 3 is before 2. 4 is before 2. 3 inversions. What matters is not the exact count, but whether it is even or odd. Even or odd mod 2 is the parity of the list. Here is the rule that makes parity worth tracking. Swap any 2 adjacent items in a list and the parity flips. 1 inversion vanished. The parity flipped. Hold on to this rule. Apply this to the puzzle. The solved sentence has 0 inversions, so parity even. The swapped sentence has 1 inversion, so parity odd. If every legal slide preserved this parity, we would already be done. But the candidate is wrong, and seeing why is the whole point. Watch a horizontal slide. A tile moves left or right into the blank. If we ignore the blank, the numbered tiles appear in the same order as before, so a horizontal slide does not change inversion parity. Horizontal slides keep the candidate alive. Vertical slides are where it dies. On a 4x4 board, moving vertically means jumping by 4 spaces in the reading order. But one of those spaces is the blank. So among the numbered tiles, the moving tile passes exactly 3 other tiles. Passing 3 tiles changes the number of inversions by an odd amount. So vertical moves flip inversion parity. That sounds like the end of the idea. But notice what else just happened. The blank moved from one row to the next. So a vertical slide flips 2 things at once: the parity of the tile order and the parity of the blank's row counted from the bottom. A horizontal slide flips neither, therefore one combination never changes. Inversions plus blank row from the bottom, modulo 2. Every legal slide keeps it fixed. For the solved board, 0 inversions, blank in row 1 from the bottom, the hidden label is odd. For the swapped board, 1 inversion, blank still in row 1 from the bottom, the hidden label is even. A legal slide cannot change this label, so these 2 boards cannot be connected by legal slides. And this gives a stronger result almost for free. Take any board position at all. Now swap 14 and 15 without moving the blank. That changes the tile order parity and leaves the blank row parity alone, so it flips the hidden label. This pairs every arrangement with exactly 1 arrangement of the opposite invariant. The 2 halves have the same size. Half of all arrangements share solved's invariant. The other half can never reach it. This is what invariants do. They turn a huge search problem into a single conserved label. A strategy asks, what move should I make next? An invariant asks, what can no sequence of moves ever change? That is why the 14-15 puzzle is so deceptive. Visually, it is almost solved. Mathematically, it is on the other side of a wall.